Section 3.4.7. In a certain city, the average 20 to 29-year-old man is 69.5 inches tall with a standard deviation of 3.3 inches, while the average 20 to 29-year-old woman is 64.6 inches tall with a standard deviation of 3.7 inches. Who is relatively taller, a 75-inch man or a 70-inch woman? Now, to determine in step 1 who is relatively taller, we first compute the z-score for a 75-inch man and for a 70-inch woman. The population z-score is given by the formula below, where x is the data value, u is the population mean, and sigma is the population standard deviation. Okay, so in the first part of the sentence it says the average 20 to 29-year-old man is 69.5 inches tall. So that tells us that the population mean for the average man between 20 and 29 years old is 69.5. And then we also have that there's a standard deviation of 3.3 inches. So sigma, the population standard deviation, represents 3.3. And then the data value for the man is a 75-inch man. So that means that x is going to equal 75. And then what we're going to do is we're going to plug it into the z-score formula. X we know is 75 minus the population mean, which is 69.5, and divided by the population standard deviation. So here we take 75, subtract 69.5, divided by 3.3, and we get a z-score of 1.67. Now we want to be able to compute the z-score for a 70-inch woman, and then rounding that to 2 decimal places. So let's come back up here to the sentence. We can see here that the average 22 to 29-year-old woman is 64.6 inches tall. So that means the population mean for women in that age category is 64.6. And then we also know that the standard deviation for women is 3.7 inches. So sigma is going to equal 3.7. And then we can see that the data value for the woman is 70-inch woman. So that means x is going to equal 70. And what we're going to do is we're going to plug that into the formula to find the z-score. Well, z is going to equal 70 minus 64.6 divided by 3.7, which gives us 1.46. Now, z-scores measure the number of standard deviations an observation is above or below the mean. As the magnitude of the z-score increases, the relative difference of the observation from the mean increases. Therefore, you're going to compare the z-scores of the two individuals. The individual with the larger z-score is relatively taller, and the individual with the smaller z-score is relatively smaller.